A clean slate, a blank canvas, an empty chalkboard. It's what we always say we want when we start a project, isn't it? It sounds so good. No constraints, no baggage from our old design, nothing but smooth sailing and a big, bright, wide world for our engineering creativity to explore. Let's see. What do we need first? A transistor, I guess. Sure. No, dang, that's not it. You know, now that I think about it, if you're trying to get a new electronic product to market fast, a blank chalkboard is about the last thing you want. If our foundry partner just handed us a huge expanse of blank silicon and said, "Here are our design rules, good luck," we'd have a pretty steep road ahead. In fact, what I'd like to have is a bunch of the work already done for me, especially all the stuff that's tedious and doesn't add extra value or differentiation to the end product. I want to waltz in with my secret sauce and quickly add it to a bunch of pre-designed, known good system components so I can get my product out the door without having to spend a year reinventing dozens of wheels. Hi, I'm Amelia Dalton, host of Chalk Talk. In this episode, my guest is Pavel Klinger of GlobalFoundries, and we're going to talk about GlobalFoundries' market-specific solutions, which I have a sneaking suspicion will get me away from that blank canvas issue I'm having. Welcome, Pavel. Thank you so much for joining me today.
Thank you. It's a pleasure to be here.
So lots of different people are designing semiconductors for all kinds of different applications, and it seems like there's no such thing as a one-size-fit-all semiconductor process, right? Don't different people need different things?
Yes, they do. And to that end, we as a foundry design technology solution to fit different markets and different application requirements. Let me explain and walk you through this slide. We are designing technologies to serve different applications in different technology nodes. As you can see, in the mainstream technology nodes, 40 nanometer and above, we are helping our customers to address their requirements for the microcontroller products, for the secure identification and connectivity products, for the smart display products, and for digital audio products. And we're also focusing on the leading edge technologies, that is the 28 nanometers and below, where we're developing leading-edge emerging memories for our customers and the connectivity technologies for our customers.
So, Pavel, I understand that the mobile sector has been a bigger and bigger driver in the semiconductor industry, with everybody carrying around smartphones and other mobile devices these days. Are you seeing that trend as well?
Yes. In fact, our vision is to enable our customers to build a cost-effective, energy-saving smart mobile devices in whatever application or market segment they compete.
Okay.
And to that end, our market-specialized solutions, our technologies that GlobalFoundries offers to the customers, based on the three main pillars. That is the technology for cost-effective microcontrollers, technologies for smart audio display and power, and technology for advanced wireless connectivity.
Okay. So we've talked about mobile devices in the abstract, but can you walk us through a specific example of what you mean?
Absolutely. I'll be more than happy to do that. If you look at the next slide, it shows an example of the microcontroller. But as you see, this is not just a simple computing device.
Right.
Now this device includes analog and high voltage circuits. It includes a lot of memory, which you need for both code storage and data storage. And it also includes a lot of logic devices to perform various digital functions that the customer expects of this complicated system on chip.
Sure. So, Pavel, when do you plan to enable this capability? Can you walk us through when we will be able to use this new technology?
Absolutely. Just look at the next slide. We are talking about the same cost-effective microcontroller. And what we show here is essentially the time schedule or the timeline for our technologies to be available and ready for the customer use. You can see that we are showing RF CMOS and analog high voltage capability fully enabled for all technology nodes down to 40 nanometers, and we are about to enable RF capability at 28 nanometer node. We have one-time programming devices, or OTP, available on every technology node down to 65 nanometer, and this year our customer will start enjoying this capability at 55, 40 and 28 nanometer nodes.
Great.
Now embedded flash, which is a very critical component of the technology enabling microcontroller, is going to be available at 130 nanometer node this year, at 55 nanometer node next year, and at 40 nanometer node the year after, which is 2015.
Okay.
Finally, when it comes to the logic platform, we are offering our technology capabilities on various logic platforms, starting from our specialized platform, which we call BCD Lite, as well as the low power platforms at 65, 55, 40, and 28 nanometers.
Okay, so another trend we see is that everything has got to be wireless these days. How does wireless fit into this system-on-chip vision you're talking about?
Yeah, very good question. In fact, wireless is no longer just wireless, just like microcontroller is no longer a simple microcontroller.
True.
Today we see a real true convergence of different functions and different capabilities for all devices, and that's not an accident. We call them system on chip. So when it comes to wireless device, it now has to be a smart device. So the microcontroller capability now is getting slowly embedded or integrated with the wireless device. So to that end, we also require not only digital devices, but also non-volatile memory to be embedded or integrated with wireless device. Of course, as a wireless device, it will have to rely on a certain analog performance, and analog devices will be also part of this system on chip.
Okay.
But also this device need to be power effective and power saving, and so high voltage devices will have to be there to manage the power management capabilities. So you can see these different blocks of the wireless connectivity device that are shown on this slide really converge different technology capability on one chip.
Sure. So we've got our system on chip and it's wirelessly enabled. With today's converged devices, people want to do things like streaming audio. What do we need to do in our design to enable these kind of capabilities?
Great question. It's no longer just a digital to analog and analog to digital conversion as it used to be for the audio devices before. Now the customer require complex algorithms for digital signal processing, noise cancellation, multiple digital functions and other functions that the end user will require. And the device also becoming smarter and smarter. All these functions are now managed by the microcontroller or specialized core device, which also require non-volatile memory to store the code, which need to be periodically updated. Now you need a non-volatile memory with audio device, and you need a lot of digital devices to support your audio functions. So as a result, you can see it's another system on chip.
Right. So Pavel, we've talked a lot about end user capabilities, and you mentioned several solutions that GlobalFoundries has to address those. Let's talk through some of those solutions and your roadmap. So some of these things require analog and high voltage, right?
You're right. And I like to emphasize that the technologies and our solutions that we are discussing today are all based on the advanced technology nodes. You may want to ask, why I need to move the analog solutions to advanced technology nodes? The next slide attempts to answer this question. The migration of the analog and high voltage solution in the advanced technology nodes are mostly driven by requirements for more digital function and more signal processing.
Right.
For example, when you migrate your analog device and add more digital functions, the user may take advantage of the logic scaling and essentially make device much more cost effective and power effective. When it comes to performance, it's also what you're observing is the much improvement of the performance. When you migrate the device from 180 nanometer, let's say, to 65 nanometer, the user may enjoy significant improvement in the device capabilities, which is shown on this slide as well. So finally, the roadmap. We have to be able to intercept the end customer schedule, the end customer timeline, and to that end, we are preparing these solutions for the near future. I would like to walk you through this roadmap in the next slide.
Great.
So next slide shows our roadmap for advanced analog and high voltage technologies. Already today we have offerings of LDMOS and EDMOS devices at 55 nanometer technology node, targeting mostly digital audio applications. This year we will enable fully isolated 5 volt extended drain MOS device. We're also working on enabling technology for highly integrated digital and power management platform at 65 nanometers.
Okay.
These devices will be available for general customer usage in 2015. It takes some time to develop devices to support various levels of high voltage up to 14 volts and above.
Sure.
Now at 55 nanometer we're also building a very cost-effective platform for mobile display driver IC. So we are focusing on two types of display drivers, for liquid crystal displays and for AMOLED displays.
Okay.
We are preparing 6 volt 32 volt option and the 8 volt 20 volt option to be available for production in 2014.
Great.
Going forward in 2015, we're also considering adding embedded non-volatile memory to this platform so that we can enable our customers to add touchscreen controller capability to the display driver and make the devices a true display controller.
Fantastic. Okay, Pavel, we also talked about wireless, and that means RF technology. Tell us how you guys support that.
In the next slide, we are showing a few snapshots of what we do to increase our customer success in the marketplace. We are focusing on 3 main areas, which are critical to enable superior wireless or RF CMOS solution. The first area is devices. This is probably the most critical area. We have to offer our customers unique, highly differentiated, very cost-effective and high-performance devices supporting RF capabilities.
Sure.
Our RF performance for our technology is on a par or exceeds the international technology roadmap for both FT, which is the high frequency, and for noise performance. The second area is modeling.
Okay.
The models describing our devices have to be very accurate, and we emphasized modeling capabilities and the silicon verified models for every RF device that we offer to our customers. And the last but not least component and area is the design IP ecosystem. We are working with the large number of IP partners, including the partners in the general IP area as well as the more specialized RF IP area, to offer our customers a full range of IP solutions addressing their wireless and RF connectivity design needs.
Great. So, Pavel, what does the roadmap for this look like?
Let me show you the roadmap in the next slide. Please don't be surprised with the relative scarcity of the solutions here, because we are already enabling our customers with RF capabilities in every technology node down to 40 nanometers.
I see, okay.
Still, we are working on adding additional solutions for the millimeter wave devices, which corresponds to the frequency above 60 gigahertz at 40 nanometer technology node. And going forward at 28 nanometer technology node, we're enabling RF capability as well as millimeter wave capability. That will happen next year and the year after.
Okay.
Going forward, and a truly advanced leading edge technology at 14 nanometer, which we are building today, we are going to enable RF and wireless connectivity capability sometime in the year 2015. I want to emphasize that this technology will be the first technology based on the FinFET devices, and we will be probably the first foundry in the world offering this technology to the general public.
Fantastic. Okay, Pavel, one of my favorite subjects is non-volatile memory. What kind of non-volatile memory support do you have?
Well, great question. Today, non-volatile memory become a part and parcel of the every technology targeting advanced smart systems on chip.
Sure.
What we offer today is essentially 3 groups of non-volatile memory devices.
Okay.
One is the E2PROM devices. Those devices are targeting applications that need extremely high number of program array cycles, or something that engineering community called endurance, and extremely low power consumption. We do have such devices offered at 0.35 and 0.13 micron technology nodes.
Okay.
Going forward, we are also enabling our NVM capability in the eFlash area, and we are going to offer eFlash and embedded flash capability at 130 nanometer node, 55 nanometer node, and later on at 40 nanometer node. So this embedded flash capability will address every customer application, including automotive microcontrollers, smart card, industrial microcontroller, and also a wireless system on chips.
Great.
Finally, OTP, or one-time programmable devices, are a very important part of the analog and wireless design today. These devices are needed for trimming, storing configurations, calibration, and other functions that are so critical in a modern design. So we do offer third-party OTP solutions, and every single technology node today down to 65 nanometers. And this year we will enable our customers with OTP solutions at 40, 55, and 28 nanometers.
Fantastic. So, Pavel, what does the roadmap look like for this?
Yeah, it's a great question, because the customer might ask, when are we going to have such wonderful solutions? I'm ready for them. Okay,
Absolutely.
In the last slide, I'm showing you the capability and the roadmap of our NVM technologies. You can see that flash technologies will be offered in 2014.
Okay.
And we're going to offer flash technology at 40 nanometers sometime in 2015. When it comes to 28 nanometers and below, the traditional non-volatile memory are no longer available, and so we are working on emerging memory solution, focusing on the spin transfer torque magnetic RAM technology, which we are going to offer sometime 2016, focusing on the wireless and automotive applications.
Okay.
There are multiple time programming device which is required for different applications, mostly in the wireless connectivity arena, will be ready with no additional masking steps added sometime in 2014. I already mentioned our OTP roadmap and the effort which will provide our customers superior OTP capability as soon as this year.
Fantastic. Well, I think that's all I have time for today. Thank you very much for joining me today, Pavel. It was a pleasure speaking with you.
It was a pleasure answering your questions and explaining customers our capabilities and technology offerings. Thank you.
For Chalk Talk, I'm Amelia Dalton. For more Chalk Talks, check out the on-demand section of eejournal.com.